Exercise 2.4, problem 17, discussion. Let's read the problem. Show that the sum of an arithmetic series whose first term is a, second term is b, and the last term is c is given by or is equal to a plus c into b plus c minus 2a divided by 2 into b minus a. It looks very complicated, isn't it? But don't worry, I think it can be easily done. So first we have to see that this is an arithmetic series and the first term is given. The second term is given, so which means d can be calculated. So d is t2 minus t1, that is b minus a. The last term is given. Okay, and we are asked to show that Sn, the sum, right, equal to this. So first term is t1 equal to a, t2 equal to b, and Tn, that is, or the last term, L equal to C. We are asked to show Sn equal to a plus c into b plus c minus 2a divided by 2 into b minus a. So how will you calculate Sn? What we normally do first, okay, let's list the formula. Okay, Sn is n by 2 into a plus l. So what we do, we calculate n here and then d here. So first we have to calculate d. So once we know d, then you can calculate. So what has happened, we have only we have a, we have L, right, and we have T1 and T2. So using T1 and T2 you calculate D. Once you know D, you can calculate N, because it is L minus A divided by D. L is known, L is the last term, that is T, and that is C. First term is A, and D we have calculated, okay, using T2 minus T1, that is B minus A. Then L is calculated. Once N is calculated, then Sn can be calculated, because n we know, a we know, L we know. So all we have to do is that we have to follow the steps for this series, that is for these values, I mean to say, for the first term being a, the second term being b, and the last term being c. That's all it is. So first step, calculate d. D is t2 minus t1, that is b minus a. Substitute a, d and l, okay, in the expression n equal to L minus a by d plus 1. So what is this? This L is nothing but c here, so last term, and the first term is a, so c minus a divided by d, whatever we calculated. Simplify and get the value of n. Then substitute the value of a, c, okay, and sorry, the substitute the value of it's L, it's not C, it is substitute the substitute a, c, okay, c is the last term, so that's why it's written c, right. Substitute the first term, last term, and n which you have calculated here in this formula, okay. So actually, so this will become n, whatever we calculated here, into a plus L is c, and simplify to get the required expression, right. So that is what actually, this is how this problem needs to be done. Let me repeat. Normally what do we do in this case is, first we calculate d, because we know the second term and the first term. Subtract and get the d. Then once d is known, we know the last term, we know the first term, and d is known, so we can calculate the number of terms. Once we know the number of terms, all you need to do is that use this formula, which involves the number of terms n, which we calculated here, the first term and last term, which is given in the problem. Simplified, you will be able to get one expression, and you have to check whether that is this expression. Okay, so let's do the problem. Given t1 equal to a, t2 equal to b, tn, that is the nth term, or L equal to c. What's the common difference? D is t2 minus t1. So d will be equal to, in this case, t2 is b, t1 is a, so b minus a. Nth term of an arithmetic series is given by n equal to, sorry, it's not the nth term, the number of term n, right, I'm sorry, I made a mistake here. The value of n of an arithmetic series, n is given by L minus a by d plus n, okay. Please make a correction in your writing when you are copying it down. This is not the nth term, the value of n of an arithmetic series is given by L minus a by d plus 1. So in this case, what is L? L is c, and a is a only, first term. And d is, we have calculated that to be b minus a. Substitute all these things, we will get n equal to c is L, A is A and D is B minus A plus 1. Take LCM B minus A, so it's B minus A. C minus A plus, so it will become, this B minus A will come up. So when you take LCM, so simplify this, what will you get? N will be equal to B plus C minus 2A. Okay, N is equal to B plus C minus 2A. We have found D, we have found N. What is next? We have to calculate Sn. That's the third step, because the expression is given for Sn. So we'll have to calculate Sn. What is Sn? Sn is n by 2 into A plus L. Okay, now let's substitute n. When n we just calculated it to be B plus C minus 2A divided by B minus A. So B plus C minus 2A divided by 2 into B minus A, that's the value of n. So divided by B minus A, and it is divided by 2, right? So it becomes 2 into B minus A, right? Into A plus L. A plus L is in our case is C. That's all it is. So if you simplify this, you will get A plus C into B plus C minus 2A divided by 2 into B minus A. This is Sn. But that is what they have told. So it is right. So that's the sum of the arithmetic series is this A plus C into B plus C minus 2A divided by 2 into B minus A. So all we are doing here is that substituting the value of n. It is given as n by 2, but n we know it is B plus C minus 2A divided by B minus A. And so it's divided by 2, the 2 comes here. Okay. So let's revise it one more time. So first thing we are calculating, well, we are taking all the three terms as A. T1 is A, T2 is B, Tn equal to L. Please write it as L. It's not Tn. It's better to write it as L. L equal to C. And find the common difference. Common difference is T2 minus T1. That is B minus A. Then you calculate the number of terms in this series. You know the first term is A, the last term is L. But we don't know the number of terms. So that is given by n equal to L minus A by D plus 1. Substitute L. L is C. A is A, D we just calculated, plus 1. So simplify it, you'll get the value of n. Then once you get n, you substitute n, A, L in this formula to calculate Sn. That's how you get this expression. Okay, I hope I made it clear. If it is not clear, please review it one more time and you will get it all clear. Thanks for watching this video.